Hello, everyone. Today we're going to solve quadratic and linear systems graphically as well as algebraically. We can solve these systems using substitution, or we can solve them when we graph them both. So example 1a, to solve a system algebraically, we have our two equations that are y equals. So I use substitution to substitute x minus 3 in for the 1y. Then that gives me x squared minus x minus 6 equals x minus 3. It's quadratic, has an x squared, so I need it to equal 0. And then I solve that quadratic. So I factor, set each factor equal to 0. And I find my two x values are -1 and 3. I then need to find both y's. So I choose one of my original equations. I substitute both x values into the y's, and I find my 2 points. I must list the solution as an ordered pair. I can solve it graphically using my graphing calculator I solve both equations for y. I then enter them both into y equals. I adjust my window to make sure I can see both graphs, especially where they intersect. Zoom 6 will give me my standard window, or I can adjust the window. I find the intersection, and I do calc menu, which is second trace, hit enter, move the cursor close to one of the intersections, hit enter, and then I repeat this for the other intersection. So let's see exactly how this works. So number one, I want us to solve these algebraically and then graphically to check. So number one, when I solve that algebraically, I'm going to take x minus 1 and put it in for y up here. So that gives me x minus 1 equals x squared plus 4x minus 5. I'm going to subtract x and add 1 to both sides. So that gives me 0 equals x squared plus 3x minus 4. I want factors of -4 that add to be 3. So that's 0 equals x plus 4 times x minus 1. Set each one equal to 0. X plus 4 equals 0. X minus 1 equals 0. That gives me the solution x equals -4 and x equals 1. I then need to find the y value, so I'm going to use my second equation. So when x equals -4, it's y equals x minus 1. I put in -4. So it's -4 minus 1 gives me -5. So that is the solution, -4, -5. I then do that with x equals 1. So it's y equals x minus 1. Y equals 1 minus 1. So that's 0. So that solution is 1, 0. So the two solutions are -4, -5 is 1 point. The other point is 1, 0. Now I want to solve that system graphically. So I'm going to graph it on my calculator to check. So I'm going to enter y equals x squared plus 4x minus 5 and y equals x minus 1. So I go to my graphing calculator, go to y equals, and it was x squared plus 4x minus 5 and x minus 1. And I'm just going to go back to make sure, check my equations. And now I'm going to graph. And you can see they both intersect. So now I do second trace. And I'm looking for the intersection, which is option 5. I'm going to hit enter from the blue equation, enter for the red equation. And now I'm going to move my cursor close to one of the intersections. So I moved it to the right one first. Hit enter, and you can see that that intersection point is 1, 0. I now want to do that again to find the second one. So I do second calc, intersection 5, enter for the red, enter for the blue, arrow closer to my other one, because if I leave my cursor there, it's just going to keep giving me back that 1, 0. So I'm close to the other intersection point. and that's -4, -5. To show my work for that, if I were just doing it graphically, I would use second table to plot my points. So now let's do number 2 just graphically. So if I want to do it just graphically, I'm going to graph y equals 2x plus 1. So that has a y-intercept of 1 and a slope of 2 over 1. So I start at 1. I go up 2 over 1, up 2 over 1, up 2 over 1. Do the same thing going backwards, down 2 left 1, down 2 left 1. And that gives me this line. And now I need to graph the parabola. So to graph the parabola, I like to make a table. And I'm going to use my calculator. So it's x squared plus 2x minus 8. So I'm going to go to y equals, and clear these out. So it was x squared minus 2x plus 8, I believe. And double check that. Plus 2x minus 8. I flip-flop my signs. Plus, minus. Then I'm going to look at my table. Second table. And again, remember, I'm always looking for that turning point. So my turning point's at -9. So that means I'm going to plot -4, 0, -3, -5, -2, -8, -1, -9, and then vice versa. So -4, 0, -3, -2, -1, 0, 1, 2. Okay, so now I plot those points, -4, 0, -3, -5, -2, -8, -1, -9, 0, -8, 1, -5, 2, 0. And that's where I stopped in my table. But you can see I only found the one intersection. So that means I'm going to look at my table again, and I need to continue so that I can find that other intersection. So I'm going to look at my table to see what 3 and 4 are. So 3 is 7, and 4 is 16. So 3 is 7, and 4 is 16. So 3, and that's my other point. So I connect that with a smooth curve. And I need to label both graphs so I know which one's which. I mean, it's kind of obvious in this case, but you still need to label them. And then I need to identify my solutions. So my solutions are -3, -5, and 3, 7. I need to make sure I find both. So I want you to pause. And I want you to do number 3 algebraically and number 4 graphically, and check them both on your calculator to make sure they're right. Okay, so my first one, number 3, I did algebraically. So I substituted 2x plus 6 in for y. I then subtracted 2x and -6 from both sides, which gave me 0 equals x squared plus 2x. I factor x squared plus 2x by taking out the common factor of x. So it's x times x plus 2. I set each equal to 0. I solve, which gives me x equals 0 and x equals -2. I then need to substitute 0 in for x, which gives me y equals 6. So one solution is 0, 6. I then substitute negative 2 in for x into y equals 2x plus 6, which gives me 2. So the other solution is negative 2, 2. Now I need to check this on my calculator. So on my calculator, I go to y equals. I'm going to enter those equations. So it's x squared plus 4x plus 6. And then my other one is 2x plus 6. I graph it to make sure I can see. I see both intersections. So I do second trace, and I'm looking for the intersection, which is option 5. Enter, enter, and I'm close to the one. So that is 0, 6. That's one solution check. I then do second trace again. Option 5, enter, enter, and now I need to move it by using my left arrow till I'm close to the other point, enter, and that is negative 2, 2. So it does check. The other one, I said I wanted you to graph it, so that means I want you to graph it on your graph paper. So I first need to solve the second equation for y by subtracting 2x, which gives me y equals negative 2x plus 5. I graph that first because I like to do the line first. So the y-intercept's 5, slope of negative 2. So that gave me the dark blue line there. My parabola is y equals x squared minus 6x plus 5. So I entered that in my calculator. I focused. So sorry about that. So again, I focus around my turning point, negative 3, negative 4, negative 3. So there's my turning point at 3, negative 4. And now I'm looking for where they intersect. So where they intersect is at 0, 5. So that is one solution. And then down here at 4, negative 3. That is the other solution. I can use my calculator again to double check those two solutions. So I go here to my calculator. I go to y equals. I'm going to change my equations to be the ones I had there. So it's x squared minus 6x plus 5. And then negative 2x plus 5. I hit graph. That looks like what I had. So I do second trace, intersect, enter, enter, enter. So the one solution, 0, 5. I do that again, second trace, 5, enter, enter. And now I need to use my right arrow to move that cursor closer to my other intersection. You'll see if you don't get close enough, it'll give you back the first one. And that's 4, negative 3. So both my solutions check. So that's the end of our video for today. We will pick up continuing solving graphically and algebraically after a break.